Welcome to the Categorizing podcast. In this podcast, we're going to learn how to categorize the substance you have so you'll know how to calculate the pH. Actually, calculating the pH of a substance, you'll need to look at the individual components. So once you know you have a weak acid, you can watch the podcast for a weak acid, and that should help you actually calculate the pH or know how to dissociate it or things like that. Okay? So, in order to know how to categorize, we have to know what our options are. And the options are going to be a strong acid or a strong base. And with the strong acids, you basically need to memorize those. There are a list of 6 acids, and I talk about this more in the strong acid podcast, but they're going to be HCl, HBr, HI, HNO3, HClO4, and H2SO4. If they're not on this list, they're not a strong acid. Okay? The strong bases are basically going to be any metal ion, so like sodium and OH. You could also have KOH. You could have MgOH2. So when you're looking for the strong base, the part that you're really looking for is going to be that OH, OH, OH. And when you look at the acids, you're going to look at the H, but just because they have a hydrogen out front does not make them a strong acid. In order to know the strong acids, you just have to have them memorized. All right, so moving on. Moving on to the weak acids. So weak acids are going to be any acid that isn't a strong acid. And the way that you know the acids are basically they're either going to start with H, like HF. Be careful with HF because it is a weak acid. HNO2, excuse me. HNO2. HNO3 would be a strong acid. So HNO2 would be a weak acid. HCN, etc. The other way you'll know a weak acid is it'll end with "-cu". So organic acids, like acetic acid, can be written CH3COOH. Some of the organic acids, the hydrogen is still listed first, and they can be written in either way. The weak bases, for the most part, are going to contain nitrogen. So an inorganic example would be NH3. That's ammonia, not ammonium, ammonia. That would be an example of a weak base, okay? I'm going to write the name of that because it's really important. People always get it confused with ammonium. It's ammonia, okay? And then organic examples would be amines. So you can have CH3 and H2. You could have CH3 2 and H. So it doesn't matter how many hydrogens you have. Actually, you could have no hydrogens. You could even have CH3, 3, and it's really that nitrogen that you're looking for, okay? That nitrogen is what's going to make it a base because a nitrogen has a lone pair. It can accept an H+. All of the weak bases are what we call Bronsted-Lowry bases, and if you want to learn more about that, you can watch the podcast on weak bases. Our last option covered here is going to be a salt. You also have the option of a buffer, but that's not going to be a single thing. That's going to be a system. You're going to have 2 things, and you can watch the podcast on buffers for that one. So your options for salts are going to be acidic, neutral, that does say neutral, and basic. And the thing you have to think about with a salt is that you have to have a cation and an anion. And in order to determine what it is, you need to break it up. Okay, so once you've broken it up, and we'll do some practice ones, you're going to cross out any pH spectators. So for the cations, it's going to be Na+, K+, Ca2+, Mg2+. There actually are more of these, but they're basically going to come from the group 1 metal ions or the group 2 metal ions. any metal ion is generally not going to affect the pH. That's not 100% true, but it tends to be true for the type of chemistry we're studying. The anions are a specific set of 5: Cl-, Br-, I-, NO3-, ClO4-. And these come from the strong acid. There's no coincidence to that, okay? So let's take an example. So let's say, for example, you have NaNO3. So we have NaNO3. First step, when you know that this is a salt. So we know this has to be a salt because we've got a cation here and we've got an anion. Usually one of the two components is something that you recognize. We've recognized Na and NO3 as a salt since the beginning of the year. So we've got to break it up into Na+, that's the cation, NO3-, that's the anion. Now let's go back and see if these are on the spectators list, and they are. Na is on the spectators list, NO3 is. If they're on the spectator list, you're going to cross them out. So let's cross them out. So we're going to cross out Na, we're going to cross out NO3. When you cross out both of them, that is going to make it a neutral salt. Let's take another example. Let's say, for example, you have NH4Cl. So we know that this is comprised of 2 ions, NH4, which is ammonium, and Cl-. And let's go back and check the spectator list. When we look at the spectator list, well, for the cations, we don't see NH4, so we can't cross that one out. But we do see Cl, so we can cross that one out. All that you're left with is the cation. When all you're left with is the cation, that makes it an acidic salt. So why would we call this an acidic salt? All acidic salts will contain a conjugate acid of a weak base. So what will happen is when you put NH4Cl into water, the first step is it will break down into its 2 components. And we don't care about the Cl, that's just going to be a spectator. But this NH4 is going to further dissociate. Now, all conjugate acids and bases are in the salts that are not neutral are going to be weak. So they're going to set up a dissociation in water in which they reform the weak base they came from and their conjugate, and they give off a proton, because that's what makes them a conjugate acid. So this is your conjugate acid, this is the weak base that it came from, and that's what actually makes it acidic. Okay, so let's try another one. In this case, let's do NaCN. So for this one, you're going to break it apart. So you're going to break it into Na plus Cn minus. So the Na plus, we know, because previous examples, is a spectator. Cn minus, we always come back to this list. Nope, no Cn minus. Okay, so the Cn minus, because it's a anion, is going to make this a conjugate base, which means that you have a basic salt. And let's show why that makes a conjugate base. So again, it will dissolve until you have just the Cn minus. And we know that this is a conjugate base. All conjugate bases are weak. All weak bases need a water to steal a proton from. So we're going to end up with HCN plus OH minus. The fact that it produces an OH minus is what makes it a base, and it will also produce the weak acid. And notice here that this goes both directions because it is a weak conjugate base. All conjugate bases are going to be weak. Okay, so okay, so here's some practice problems. I suggest if you want to try these on your own, you pause the recording because I'm just going to go over them right now. All right, so let's look at the first one. The first one is KClO4. We know that this is a salt because we clearly have a cation and an anion. And in order to deal with this, we need to break it into its components. We've got K plus, ClO4 minus. If we look on our list, this is a spectator. This is also a pH spectator. So this would be a neutral salt. Okay, so the next problem. HC2H3O2. Well, we know this isn't a salt because we don't have two different components, but we do notice that we have a hydrogen out front. So that's going to let us know that it's an acid. This is not one of the 6 strong acids, so by default it has to be a weak acid. Okay? All right, so if we take a look at the next one, we have NaOH. Well, we've got a metal ion, right? And in a way, you can kind of think of this like a salt too, because you can break it into the Na plus and OH minus. And if all you're left with is OH, you obviously have a strong base. We also know this is a strong base because all of the strong bases are Arrhenius bases. They'll all be a metal cation and a OH minus. All right, so let's take a look at the next one. So the next one is CH3NH3Cl. This is obviously a salt because we can see the Cl minus. This group of it is a little bit harder to tell, but if we've got a Cl minus here, we know that that has to be ionically bonded. So we're going to have to split it into its 2 components. So we've got CH3. When you break these up, it's always going to break up right on that ion line, okay? CH3, NH3 plus, because you have to have a cation and an anion, and then Cl minus. Cl minus is on the spectator list. This is not. So because you're left with a cation, this has to be an acidic salt. So this would dissociate and produce H+. Just like an acid would, what makes it an acidic salt is that it will also be highly conductive in water. All right, so the final one, HI. This is on the, obviously it's an acid. This is on the list of the strong acids, so it is a strong acid. All right, let's do one more practice set. All right, so again, I would highly suggest you stop this and you actually practice this on a sheet of paper or whatnot. I'm going to go over the answers. So let's see if you get them right. All right, so the first one has a OH, and it's attached to, it's bonded to a metal ion, right? Ionically bonded. So this would be a strong base. Okay, if we look at the next one, we notice it's got NH, but the NH isn't followed by anything like a Cl or an NO3 or whatever. So this would just primarily be this would be a weak base. Okay, let me change colors so you can see the next one. So if we look here, the next one we see Na, so obviously this is going to be a salt. So it's going to split right where you would expect it to, right with the Na, because you know we're going to have Na plus, and then we're going to have whatever else is left over has to be our minus. Okay, this is a pH spectator. Since we're left with just an anion, this is going to be a basic salt. Okay. And then if we come down here to the next one, we've got HClO4, obviously an acid. It is on our strong acid list, so just by memorization, we know this is a strong acid. And if you look at the next one right here, it's very close in chemical formula to the one above, but if it is not on that strong acid list, it's not a strong acid. So even though it's only off by 1 oxygen, this would be a weak acid. Okay, I hope this helped.